Hey, it's Joel, and it is time. It's finally here. The OpenRC project is upon us. It's finally time.
Joel, I think Mark Rober sent you a message.
Mark Rober. Oh, I love that guy. Yeah. Put it on the screen.
Jeez, Joel, it's about time. You're worse than me, and I only make 12 videos a year.
Man, oh, that Mark. He's right, though.
Welcome back. Hey, thanks, Mark, for that inspiring message. Awfully kind of you. It's time, though. It's actually literally time. This isn't like we're going to go test out the OpenRC car. We've squashed bugs. We've retrofitted. We're using more metal parts in the OpenRC F1. The world's largest OpenRC F1 is finally set to drive. And before you see it, we did do a couple things to it. So one was this axle was destroyed. I had to reprint it. And I don't have a machine that's this wide. I had to do it in parts, and I'm going to show you how I put that together. Plus, we have bearings now, actual honest to goodness real bearings. And what we need to do is build shims so that they fit within the spaces needed. So, well, have a watch. All right, there we go. This is it. This is most of it.
We're gonna clamp it all down to make it aligned.
There we go. Those are the right words. That's it!
You did it. Well done, man.
Dude, bring it in.
You're still going to have a lot of friction, and friction makes heat, and hot
Friction
plastic
does make
makes
heat,
melty
yeah.
plastic.
It does, yeah. Oh, yeah. Wow, it totally dug into the plastic right there. As you know, July has been the month that we've designated that we're going to get this OpenRC F1 car going. And by going, I mean legitimately able to drive down the street. Filmed with a drone. I've got a new axle. This is actually just like the old axle. It's not a single piece. What I was able to do is bring the STL into Fusion 360, convert it to a B-rep, and then make cuts and slices into it. And so I don't know if you can see right here, but I made kind of a puzzly cut right here. And I left zero room for tolerance because I just wanted to force them together and have that space be minimal between the pieces. But what I also did is I coated each side in 3D Gloop, and that 3D Gloop is wonderful stuff. And I think this axle is gonna hold. I think the plastic will probably give out before the 3D Glooped pieces. There's a couple of spaces, like right there and right there, where I can drip a little bit more Gloop in, but I'm not too worried about that. Also, bearings. We have bearings now. And these are the bearings, this big one right here. These are the bearings for the rear axle. We can't get bearings the exact size of the bushings that we had before, but what we did is we got close, and then I created shims. So if you look, here's the axle, the rear axle, and if that goes over, there's a little bit of play right there, and we don't want that. So what I did is made a shim to give us a space between what we had and what we needed. And if you look, oh, fits perfect, it fits so good. And then it goes right there. It spins really great. There's no play, and that shim works really well. For the shim, I didn't want to use PLA at this point because I wanted something a little bit more, not rigid, but more robust. Something that could probably flex a little bit more just in case. And so what I did is I used ABS, and I used the FunMat HT from Intamsys. And the reason I did that is because as a machine that can print ABS, it is fantastic. And I didn't want any layer adhesion problems. I didn't want any bed adhesion problems. I've had nothing but fantastic ABS results with that machine, which hopefully you'll see at some point in a video, unless it's already out. So this is on this part right here. In fact, here, these are the bearings right here. So the inner diameter had to be shrunk just a bit. The outer diameter is fine. And now this is perfect. Oh, that's good. That's good right there. One of the things I wanted to explain when making the shim, I used a little bit of extra space here. This shim thickens the bearing just a little bit because the space needed was thicker than what we had for bearing. So that's why that's there. And that's important when we go to these front bearings. So these are the bearings that will go on the front axles. There we go. So I've got two shims for the front bearing, and there's two per axle, one on each side of the rim of the tire so that the axle sits nice. because of this bearing's inner diameter and the outer diameter were smaller than what we needed, I needed to create 2 shims, one for the outside, one for the inside. I also needed to create something to thicken it, but I wanted it to ride center. So what I could have done is created something similar to this that had 2 walls that shimmed it and then just kind of held it like that. But because the inner race operates independently from the outer race, I think that's what they're called, I couldn't do that. So I made an inner shim and I made an outer sleeve. Here's how that works. The inner shim goes in just like that. Then the outer sleeve goes in just like that. It's a great fit. And this shim turns just fine. This shim turns just fine. And the reason that they're a little bit thicker is because the bearing was 7 millimeters thinner than what I needed for that, where I had a bushing. So each of these shims extend further 3.5 millimeters, which means the bearing is going to ride center. And as the axle's going in on either side, it's going to be spaced great. And we're going to have real actual bearings. Real bearings. This is fantastic news because really the only deficit that the OpenRC car had before was that the friction caused the axle and the bushing to deform, which meant that that tight connection for the belt then loosened up and it couldn't drive anymore. So with the bearings in place, we're not going to have that friction issue. We should be good to go. We're going to get these in the car and then we're going to drive it. And I'm kind of really excited about this. So there's your update.
Now, for the moment I've all been waiting for.
Here we are, we're back at the school where it all last started. Last time we were here, we were somewhere over there where little kids are playing, and we tried to make it go. The problem was the friction with the fully plastic bushings didn't cooperate, and so we melted things together. Yes, I know the internet told me, but I had to try. Since then, like I've said, there's bearings on all 4 wheels, and I've got tail stabilization on the motor, so it's not gonna drift or pinch towards the back gear, the back axle, the sprocket, right? The sprocket. I've tightened everything up. There are now more bolts where there should be. It's time to actually test this out and watch it go. Count it down. 5, 4, come on, 3, 2, 1. There we go. It worked. That was wonderful. That was actually awesome. It's great. Unlike a real sports car, there's no suspension in this whatsoever. So any small little dent in the road, any small bump, and it could cause trouble. It actually could be fatal to this. But at this point, I think we've proven that it works. Now it's time to up our adventure and let's go get some coffee. Are you happy now? This is a cup holder, and I printed this in Matterhackers Pro Series PLA on my CME CNC Artemis using a 0.8 millimeter nozzle because I needed it to go fast. I did this last night after getting home super late at night. This is gonna hold a 16-ounce Americano with caramel and a little bit of cream, most affectionately known as a Big Joel. We're gonna drive up to the coffee shop. I'm gonna order a coffee. They're gonna put it in here, and then we're gonna drive the coffee back to me. And We'll see what happens. Okay, here we go. I'm just having to course correct every little bit. I'm gonna have to gun it up the hill. Go, 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 go! This is a big hill. I'm out of breath. Hello. Could I get a large Joel, please? I want to ride a car next time. Yep. Go ahead and put that in the coffee holder, please. This was a lot of fun. We made it up to my coffee shop. Thank you for the wonderful coffee. Okay, they said you're welcome. Good. Oh, I deserve this. That was a heck of a run. Walk up that hill, whatever. This is a far cry from what it used to be. It successfully not only did loops in the parking lot, but this car also made it to the coffee shop 3 or 4 blocks away. It went up a pretty big hill. It was gonna go faster than I could go. We'll try to get it going faster. The cup holder worked, the tail stabilization worked, the bearings worked. I'm just super happy at this point. Thanks for coming along on this journey. I'm gonna sip this coffee and just relax for a bit. Hug each other more. I love you all. As always, high five. Okay, let's do this.
I was born to roll.
I'm driving backwards, so no, it ran out of battery. It's a little bouncy. It's a little bouncy. Go, 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 go. Okay. Yeah, go ahead and park on the other side. We're dead. No!
Later.
Oh, hello. So you might be wondering what you see in front of you here. This is a 100%-ish plastic OpenRC F1 race car, scaled up to 400% scale, and it's in pieces. And that's because when you drive a plastic car on the real road, real accidents happen. And I think Sean got on camera. We have an electronic brake on the motor here. The speed controller has it, right, Robert? It wasn't powerful enough. So as we're going down this hill, unfortunately, it was big plastic car versus a Tesla tire, and the Tesla tire won. So, not too bad though. If you think about it, this has seen better days. It did crack off, and that's because this part right here hit the Tesla tire, but the 3D Gloop didn't fail. Go figure. Both of the front axles snapped off. The bearings, you can see, this is the ABS, and it was handling just fine. It still spins just fine, but again, that's just PLA plastic, and PLA plastic versus a real car tire, we all know who's gonna win that. The tires are fine. All 4 tires are totally fine. This axle snapped right there. And the servo that actually steered the car was only held on with hot glue, and it held well, right, Robert? It did. Except, again, when it's versus a real car. All in all though, I'm gonna consider this a huge, massive success, because not only did we do the loop like we were gonna do last time, we drove it up to the coffee shop, we got coffee, we sat down, we had a moment. It was wonderful. And on the way back, if it was Icarus, it flew too close to the F1 sun. Going forward though, this isn't the last you're gonna see of this car. Obviously, these are the parts that broke, but what's great is this gives us an indication of where failures can happen when using 100% plastic. So stuff like these front axles, those could be machined out of metal. The tires are good, the rims are good, or the wheels are good, whatever, I don't know, people correct me on the internet, so it's fine. The bearings are good, the main body's good. I mean, it's still all in one piece. Even the, what is that? The the fender, not the spoiler. Thank you, the spoiler. Even the spoiler, like I thought that was going to be the thing that broke, but it's not. Well, I thought this was over at the coffee shop. It's now over at the bottom of the hill. Well, now, thanks for watching. I appreciate you along this journey. I know it's about time. We'll see you in the next one. Hug each other more. I love you all. And as always, high five.
This is insane.